All right, so number 14, I know that this is a hyperbola because it says hyperbola. Now with the hyperbola, it could either be like this is a vertical one, or it could be a horizontal one like this. How can we tell either case? Yeah, whatever term is the positive. So if y is positive, then it's going to be this. If x is positive, then it's going to be this. So since y is positive, it's got to be this one right here. Okay? So we're going to write down a couple things to help us when it comes to the graph. Okay, so number one, I'm going to find the center. So center is going to be 0, 0. Okay, just because there's nothing with the x and the y. All right, and then the vertices. The vertices is the distance from the center up to right here. Okay, so that we find that from the a value. Okay, so this is going to be the a value right here. So the a value is underneath the positive. So a is going to be the square root of 4, which is 2. And then here we have the b term, which is going to be the square root of 20. So the square root of 20 comes out to be something. I think it's 4.5 or so. Okay. Now with that information, that's enough to go ahead and do the graph. I'm going to show you guys the equations of the asymptotes and the foci after we graph it. So moving over here, let's start with the first thing. We're going to plot the center, which is 0, 0. And then since it's a vertical one, we're going to use our a value and go up to find our vertice for our parabola. So it's going to be coming up like that. Okay. So I'm going up 2 and I'm going down 2. And so the parabolas are going to be coming up like this. Now, how do we figure out how wide the parabolas are or how skinny? Well, that's where the b term comes in. Okay, so I'm going to take this b term right here, and from the vertice, I'm going to go over 4.5. So 1, 2, 3, 4.5 is about right here. All right. Now, from my other b, I have to go this way, and then from this b, I have to go over 1, 2, 3, 4.5. Okay, so then I'm just going to keep doing this. All right. Now I'm going to create like this, almost like a little box. And that's going to be what I use to draw my asymptotes. Okay, so here's the asymptotes. That one's a little bit crooked, but you get the idea. All right, so then from here, I know that my parabola is going to be opening up. So I'm going to go like this, going up like that, this one, like that, this one, like that. Okay, so there's the hyperbola with all the information that we need. Okay, now a couple other things, I guess, is we need to find the foci. And the foci is taking the square of a, which is 4, and you're kind of fat. Let's trim you up a little bit. Okay, so that's going to be 4 plus 20 will equal our c squared. Okay, so a squared plus b squared equals c squared. So that'll be 24. So the square root of 24 is going to be our c. Now the square root of 24, I don't know what it is offhand, but I think it's like 4.9, I think this is approximately 4.9. Okay? So from the center, this center right here, from that center, I'm going to go up 4.9. So 1, 2, 3, 4.9. That's where my foci is. So from here, 1, 2, 3, 4.9. Okay, so that's the foci. Now the equation of the asymptotes, this is how this works. Obviously, this is the line because it's a line, right? Okay, it's straight. So each line has a slope that has the rise over the run. Now this one is up to over 4. So the slope of this line, the m, is up to over 4.5. Now do you guys see how this looks weird? Like you can't really have a fraction with a decimal in it. That's like strange. So what I want to do is I want to try to convert this to be like, well, I know if I multiply 4.5 times 2, doesn't that get rid of the decimal? Okay, so what's 4.5 times 2? That'd be 9, right? And then I'd have to do it to the top as well, so that'd be 4. So the slope is going to be 4/9. So to write the equation of this line, it'd be like this. Y equals 4 over 9 x. Okay? And it crosses 0, so that means the y-intercept is at 0. Now this one has a negative slope, so it's going to be exactly the same though. So y equals negative 4 over 9x. That's how you write the equation of the asymptotes. Okay, that's a good problem. Alright, so next it says find the equation of the conic section, and it's a parabola, okay, and it's giving you some information here. So it says the vertex is right here, and then the focus is this. So initially what I want to do is kind of plot out the situation and know and try to figure out what equation I'm dealing with, a C, backward C, or happy face, sad face. So the vertex is at 2, 1, and then the focus is at 2, -1, so it's right down below. Okay, so watch, I'll make the focus red. So if the focus is red right here, and this is the vertex, so if this is the focus and this is the vertex, is this going to be a happy face, sad face, or a C, backward C? Yeah, it's gonna be something like this. Now I don't know how wide it's gonna open, but I know it's gonna be going down because the focus is right here and the vertex is right here. So that means that my equation is gonna look something like this, where y isn't squared, and then I'm gonna have a negative a term, right? And then it's gonna be x minus h squared plus k. Now they give us our vertex, and the vertex, remember, this is gonna be your h and this is gonna be your k. So we can already start to fill this thing out. So it's gonna be y equals negative a, and then x minus 2 squared plus 1. Okay, now all we got to do is just figure out what the a term is. Now there was a connection between the a and this distance here. Do you guys remember this distance? Good. So absolute value of a equals 1 over 4c. So c is this distance right here. So that is, well, 1, 2. Okay. So if c equals 2, what's 4 times 2? 8. So watch this move. Bam. Okay. So that looks ugly, so I'll do it again. Looks like the Grinch or something. So negative 1/8 and x minus 2 squared plus 1. Okay. So that is the equation of that parabola. Good? Alright, now the next part is easy because it says identify the shapes of the graphs. This one squared variable, parabola, good. Okay, 2 squared variables with different coefficients. Both of them are positive. What's that? Good. Ellipse. Why don't you guys figure out the other two? And I will move on to this guy right here. So, solving a system works like this, where if you have a 3-variable system, you need to somehow try to make it into a 2-variable system, and then from there you need to try to make that into a 1-variable system. If you can do that in this sequence, then you'll be all set, and that's how you get your answer. Okay? So right now I see 3 variables, but I like equation number 2 because equation number 2 only has 2 variables. So I'm going to pull that guy out, and I'm going to say I want to find another or I want to somehow create another 2-variable equation to have a 2-variable system. So let's take equation 1 and equation 3, and let's try to make that happen. So what should I do to equation 1 and equation 3? Okay, which one? Should I make the top or the bottom negative, or multiply by -1?
The top.
Good. Why the I agree with you. I think the top is a better choice than the bottom. Why? You just guessed? Okay, well, good guess. I would do that because looking at this, when I start to subtract these, it's like, man, I don't like dealing with negative numbers. So I try to think smarter, not harder. So the x's cancel, and then I have negative 2y, and that's going to be negative y. And then right here, this minus this is going to be positive 2z. And this is a 7. Okay, so there's my next equation that I'm going to pair up with this. So I'm going to just take that guy and move it over here. So I got negative y plus 2z equals 7. Now this is great because, look at that. The y's are going to cancel. See, so we went from the 3-variable. Now we're down to a 2-variable. We're going to make it into a 1-variable. See how those y's are going to cancel? And I'm left with 4z equals 12.
Yeah.
So then z equals 3. Now if z equals 3, this is when it becomes fun. Sort of, okay? So 2 times 3, that's going to be 6. Subtract 6 from either side. So 5 minus 6 is -1. So y equals -1. Now to figure out what the x value is, I'm just going to take one of the equations. I'm going to take the top equation before I multiplied everything by -1. So equation 1, here's x plus 2, and I'm going to substitute in my values, and then I plus the z equals 1, okay? So y equaled -1. And z equaled 3. That's going to be -2. So -2 plus 3 will be +1. So I have x plus 1 equals 1. Subtract 1 from both sides. Okay, then I get x equals 0. So what does that mean? If I get x equals 0, does that mean that it's no solution? No, right? Okay, it's okay to have x equals 0. Right? So if x equals 0, this is our solution. The solution is an ordered pair, and don't forget the order. That's why it's called an ordered pair. There's a particular order. This is your x, this is your y, this is your z. Okay?